This is a recast of the 5,800-word piece, Natural Language Processing, NLP, from Chatbots AI. This article discusses the fundamentals of natural language processing, NLP, and its applications in various industries, as well as the challenges it faces. Let's listen in.
Natural language processing, often shortened to NLP, is a field of computer science and artificial intelligence that focuses on enabling machines to understand and process human language.
In other words, NLP is the technology used to break down natural language and make sense of it for computer applications, such as sentiment analysis, machine translation, chatbots, and speech recognition. The development of NLP has been driven largely by the ever-increasing volume of digital data, resulting in vast troves of unstructured text, voice, and video that require analysis.
NLP has already been applied to a range of applications, from virtual assistants to sentiment analysis and language translation, but it still has a long way to go before it can truly match human understanding of language. So why is NLP so important? Well, with the explosive growth in the amount of data being generated every day, NLP is essential in analyzing and understanding the information available.
It's being used for a variety of applications, such as healthcare, customer service, finance, and legal industry. For example, in healthcare, it's being used to analyze electronic medical records and improve medical outcomes. In customer service, it's providing chatbots that can communicate with customers in natural language. It's also being used for document analysis and contract review in the legal industry. Although NLP has made great progress in recent years and is enabling us to interact with machines more naturally, there are still some challenges that need to be addressed.
For example, due to context ambiguity, different phrases and words can have different meanings depending on their context, which can make it difficult for machines to understand. Additionally, there are still concerns about data privacy and accuracy when using NLP in the legal industry.
Right? Well, let's take a look back at the development of NLP and how it's gotten to the point where it is today.
The 1950s marked a turning point for the field of NLP. Researchers started recognizing the importance of NLP and began developing computational approaches to analyze, interpret, and respond to human language.
One of the most significant early discoveries in the field was the use of Markov models for text analysis and predictive text writing. This development provided the foundation for the application of machine learning techniques to the field of NLP.
Early developments in NLP encompassed a range of linguistic theories and computational models that helped to lay the groundwork for subsequent research. Transformational grammar was developed to help describe the underlying structures of language and the rules by which they combine, while statistical language processing used mathematical algorithms to analyze text and extract patterns.
That's right. These early advances were important for laying the groundwork for today's breakthroughs in NLP.
Absolutely. Fast forwarding to today, current applications of NLP range from virtual assistants to news mining and speech generation.
There's also sentiment analysis, which is the process of identifying the emotional tone of a piece of text, like a movie review or a social media post. NLP techniques can analyze the language used in the text and determine whether the sentiment expressed is positive, negative, or neutral.
This can be incredibly useful for businesses that want to monitor customer feedback or for political campaigns that want to track public opinion.
That's right. And there are several techniques involved in natural language processing, NLP. Some major NLP techniques include named entity recognition, NER, sentiment analysis, part of speech, POS tagging, tokenization, and stemming.
With all of these techniques used together, we can develop more accurate and effective systems for natural language understanding.
Yes.
The same algorithms are used in text clustering, which is the process of grouping similar documents together into clusters based on their content.
This has many applications like document organization, sentiment analysis, spam filtering, and recommendation systems.
Moving on to sentiment analysis. This is the process of analyzing natural language text to determine the emotional tone behind it. The goal is to determine whether the text expresses positive, negative, or neutral sentiment, and to what degree.
It can be used to analyze customer feedback, social media posts, and online reviews. There are challenges with understanding sarcasm and context, although it has made significant strides in recent years.
Then there is named entity recognition, which is a subtask of information extraction in natural language processing that aims to locate and classify named entities in text into predefined categories, such as person names, locations, organizations, and others.
This is evaluated using precision, recall, and F1 score metrics. It has numerous applications in various fields, such as information retrieval and question answering.
And let's not forget machine translation. This refers to the process of automatically translating written or spoken language from one language to another. It can be used to break down language barriers and facilitate communication across the globe.
But there are still challenges with accurately translating idiomatic expressions, puns, and cultural references.
Yes, there are still many issues with accuracy and scalability when it comes to NLP. Question answering is a challenging task as it requires a deep understanding of context and meaning. In speech recognition and synthesis require a lot of computational power in order to understand complex linguistic patterns and accurately transcribe and generate speech.
Lastly, there are concerns over privacy and bias in NLP systems, so developers must be particularly careful when considering these issues.
But despite these challenges, there are still a wide range of practical applications for NLP. Let's start with healthcare, where NLP can be used to extract and analyze data from electronic health records to make predictions about health outcomes.
In finance, NLP can be used to analyze financial statements and news articles for investment decisions and market predictions. And in education, NLP can help personalize learning experiences for students based on their needs and preferences.
Chatbots are another growing application of natural language processing, as companies aim to streamline customer service operations and provide 24/7 support. However, chatbots have some limitations, such as difficulty understanding complex or emotional issues, so there is a need for a balance between the use of chatbots and human intervention.
Language learning platforms also benefit from the use of NLP, which can generate instant feedback and offer interactive exercises that adapt to the student's proficiency. Additionally, NLP can help identify language difficulties and provide targeted exercises to help improve those areas.
Email filtering is another area where NLP is used. Algorithms can be trained to identify spam emails or important information, such as financial records.
On a more serious note, NLP is increasingly being used to detect fake news and propaganda in order to promote a more informed public discourse. Algorithms can analyze the language of content to identify patterns or anomalies that suggest a piece of information may be false.
Finally, NLP is also improving search engine results by understanding user queries and providing more personalized and accurate results. For example, Google has implemented natural language understanding to better interpret user searches.
As we can see, NLP is making a huge impact on the way we interact with technology. But what are the current challenges and future directions of NLP?
Well, current challenges include improving the accuracy of various tasks like machine translation, sentiment analysis, and question answering. Machines still struggle to interpret context and handle language with complexity and nuance.
In the future, researchers are exploring ways to use NLP for advanced applications like natural language generation and complex reasoning and decision-making. Additionally, there is an ongoing need to expand the scope of NLP to handle new languages and dialects while addressing biases in language models.
Yes, continued development of language models is essential for advancing NLP. We've seen a lot of progress over the years due to the transformer architecture and large-scale language models, such as GPT-3, but there's still work to be done in terms of improving context awareness and reasoning abilities.
That's right. Another important area of research is addressing bias in NLP algorithms. To ensure an unbiased algorithm, it's important to recognize different forms of bias that can be present in training data. One approach is to make sure the data used for training is representative of the entire population.
Additionally, there are methods for detecting and correcting bias before the algorithm is applied to real-world data. Finally, it's important to have diverse teams working on NLP development to identify any possible biases.
On top of this, researchers are also exploring ways to enhance the interpretability of NLP algorithms. Explainable AI, XAI, methods like feature importance scores, explanations for model predictions, and interactive visualizations can help us gain a deeper understanding of how algorithms are making decisions and identify potential biases or limitations.
Lastly, improving the performance of NLP algorithms with low-resource languages is a challenging task. The lack of resources restricts the development of effective NLP methods, so researchers are leveraging transfer learning and data augmentation techniques to bridge the gap between high-resource and low-resource languages.
Since NLP is such a sprawling field, let's recap the main points. NLP technologies enable us to interact with computers and other devices in more natural ways, like using voice commands. It can also be used for sentiment analysis and personalized tutoring systems.
NLP is making strides in understanding context, understanding languages, and balancing ethical implications. It has potential applications in healthcare, education, finance, and other industries.
With continued research and development, we can expect even more advancements in this field in the near future.